This lecture is about collaborative filtering. In this lecture, we're going to continue the discussion of recommender systems. In particular, we're going to look at the approach of collaborative filtering. You have seen this slide before, where we talked about the two strategies to answer the basic question, where user U like item X. In the previous lecture, we looked at the item similarity. That's content-based filtering. In this lecture, we're going to look at the user similarity. This is a different strategy called collaborative filtering. So first, what is collaborative filtering? It is to make filtering decisions for an individual user based on the judgment of other users. And that is to say, we will infer individuals' interests or preferences from that of other similar users. So the general idea is the following. Given a user U, we're going to first find the similar users, U1 through UM, and then we're going to predict the U's preferences based on the preferences of these similar users, U1 through UM. Now, the user similarity here can be judged based on their similarity in preferences on a common set of items. Now here you can see the exact content of item doesn't really matter. We're going to look at only the relation between the users and the items. So this means this approach is very general. It can be applied to any items, not just the text objects. So this approach would work well under the following assumptions. First, users with the same interest will have similar preferences. Second, the users with similar preferences probably share the same interest. So for example, if the interest of the user is in information retrieval, then we can infer the user probably favor SIG-IR papers. Right? So those who are interested in information retrieval research probably all favor SIG-IR papers. That's the assumption that we make. And if this assumption is true, then it would help collaborative filtering to work well. We can also assume that if we see people favor SIG-IR papers, then we can infer their interest is probably in information retrieval. So in these simple examples, it seems to make sense. And in many cases, such an assumption actually does make sense. So another assumption we have to make is that there are sufficiently large number of user preferences available to us. So for example, if you see a lot of ratings of users for movies, and those indicate their preferences on movies. And if you have a lot of such data, then collaborative filtering can be very effective. If not, there will be a problem, and that's often called a cold start problem. That means you don't have many preferences available. So the system could not fully take advantage of collaborative filtering yet. So let's look at the collaborative filtering problem in a more formal way. And so this picture shows that we are in general considering a lot of users, we're showing M users here, so U1 through UM. And we're also considering a number of objects, let's say N objects, denoted as O1 through ON. And then we will assume that the users will be able to judge those objects. And the user could, for example, give ratings to those items. For example, those items could be movies, could be products, and then the users would give ratings 1 through 5, let's say. So what you see here is that we have shown some ratings available for some combinations. So some users have watched some movies, so they have rated those movies. They obviously won't be able to watch all the movies, and some users may actually only watch a few movies. So this is in general a sparse matrix. Right? So many entries have unknown values. And what's interesting here is we could potentially infer the value of an element in this matrix based on other values. And that's actually the central question in collaborative filtering. And that is, we assume there's an unknown function here, f, that would map a pair of a user and object to a rating. and we have observed some values of this function. And we want to infer the value of this function for other pairs that don't have values available here. So this is very similar to other machine learning problems where we know the values of the function on some training data set, and we hope to predict the values of this function on some test data, right? So this is a function approximation. And how can we figure out the function based on the observed ratings? So this is the setup. Now, there are many approaches to solving this problem. And in fact, this is a very active research area. Recently, there are special conferences dedicated to the problem. RECSYS is a major conference devoted to the problem.